Welcome back. Today we are going to jump into transformations and look at rotations. And a rotation is a spin or a turn where we're actually going to rotate it. When we talk about rotations, we talk about two different directions. We have clockwise, which is often just written as CW, and we have counterclockwise, or working our way back around the clock. So counterclockwise is often CCW. So if you see those, you'll understand, oh, clockwise, counterclockwise. When we're looking at moving or rotating, most often it's around the origin. And remember, the origin is here in the middle. And for every time we move, it's worth 90 degrees. So what's really cool is when we have a 180-degree turn, we will be working diagonally. We'll go across the origin. So if it's on the right hand or quadrant 1, it will move over here to quadrant 3. Or if it would have been in quadrant 2, it would have moved to quadrant 4. Now if you notice, it doesn't matter which way we turned. So here we were turning clockwise, to where on the right over here we were moving counterclockwise. But 180 degrees is going to go 2 quadrants, either direction. So 180 degrees, it doesn't matter if it's clockwise or counterclockwise. It's just going to move from one quadrant to the diagonal of the other quadrant. Now, where it does matter is when we're talking about if we're only moving 1 or 3 . And so if I think here, this is my start. This is what we call, ooh, let's look at this word. This is what I'm going to call my pre-image, the original. The original one is known as the pre-image. If this is my pre-image and I'm spinning it, for every quadrant I move it 90 degrees. So this would be at 90 degrees. If I go to the next one, this would be 180 degrees. My next one would be 270 degrees. And if we went all the way back where we started, we would actually made a full circle, which is 360 degrees. So every time you move a quadrant, you are adding 90 degrees to your rotation. So taking a look here, let's first of all think, what's my pre and my image? My pre-image is right here. So here's my pre, and I'm going to be moving over here. How far did we move? Well, we moved either 1, 2, so 2 quadrants is 180 degrees. Or we could have went the other way and it still would have been 2, right? Diagonal to diagonal. That's 180-degree rotation. And we want to just look at the coordinates real quick. This is kind of cool. So I'm just going to pick one. I'm going to pick S here and I'm going to label it. My S coordinate, if I was to write it, if it asks you where S is located at -1, -4. Well, let's check it out in this quadrant. My new S, my image S, is located at, if we were to write this, 1, 4. Oh, the numbers didn't change, right? It's the exact same, but we're just changing up our positives and our negatives in this case. We're going from one quadrant to the next quadrant. It would happen to work the same way for each one of these. So for R, for instance, this is at 8, 1. And our R here is at -8, -1. Okay, so it's all about the positives and negatives. So when we see a rotation that's 180 degrees, now this only works for 180 degrees, our coordinates are all about positive and negative. That's the only thing changing. But it's a little different when we look at this type of a rotation. And we can say that this is rotated. Now remember, this is our pre. Remember that little apostrophe tells me it's the new one. So my pre started here. This was where I started, and then I moved. Now I could say I moved this direction 1 quadrant. So that would be backwards, right? So this would be 90 degrees counterclockwise. Or I could say I went 1, 2, 3. That would be 90, 180, 270 degrees clockwise. They're going to be the same. It just depends on which direction you need to move. And I'm going to put over here that this could be 90 degrees or this can be 270 degrees. Now check out the coordinates. Okay, let's check that out. Let's look at G. I'm going to be here at the G. Let's go ahead and write a coordinate for that. Where are we at for G? Well, looks like we're at the X value of -5 and the Y value of, that's -7. Okay. Well, what about my G over here? My G over here is at 7, -5. Huh. Looks like my 5 and 7 flipped, right? Now, positive and negatives are going to be different depending on which quadrant you land in. But if you just look at the numbers without the positives and the negatives, the 5 and the 7 flipped over. What about the F here? I'm going to look here. This is at 0, -7. Well, I'm going to look at this F. Where is it at? This is at 7, 0. Well, now that's interesting. Let's try the E. This E is at 10, -4. Would my E here be at, oh, there it is, -4, -10. So it looks like when we're looking at these, to get the numbers straight, we just need to figure out which quadrant we went to, and then we can flip the numbers. Now, if you have to write them, you need to be really careful about the positives and the negatives, because that's going to be kind of difficult. That's going to be the trick. Make sure you're on the right one. So this looks like 10, -9. So that means that this should be -9, -10. So careful with the positives and negatives, but it looks like we're going to flip the X and Y value and watch out. I should put a Y here. X and Y value and watch out for positives and negatives. So let's look at a couple of examples. Graph the image 3, -7 after rotation 90 degrees counterclockwise. So we're at V and we're going backwards, right? We're going to be up here. Okay. So if I'm going to go backwards, now where am I at right now? I'm at 3, -7. Now if I'm going to move up here, I'm going to use the 7 first. I'm going to go to 7 on my X and go to 3. So this would actually be 7, 3. What about this image? 270 degrees clockwise, going forward. 270, that's 3. So I'm going to go 1, 2. I'm going to end up over here. So what I'd want to think about is if I labeled each one of these. So like if I look at F here, F is 7, -1. So my F up here would be, well, we'd flip it. It'd be 1, 7. So here's my new F. Okay, my E was 7, -3, which means it would be 3, 7. Okay, my G was, this looks like 2, -1, so I would be at 1, 2. Here's G. And D is at 2, -3. So now it's going to be 3, 1, 2, 3, 2. And you have your new rectangle. So one more here. This one is here at 180 degrees. So remember, if I'm in quadrant 1, I'm going to be in quadrant 3. I'm going to go across. I'm going to go diagonal. Now here it was not about changing or flipping the numbers. It was about keeping the same numbers. We're just changing our positives and negatives. So F is at 7, 2. So F is at 7, 2. So I'm going to come over. They're just going to be the opposite. So negative 7, negative 2. Okay. Here's F. G was at 8, 2. So now it's going to be at negative 8, negative 2. So it's over here. And that's my G. And H way up here was at, looks like 8, 10. So we're going to flip that, and that's going to become negative 8, negative 10. And I would find my H here. So I'm just going to go ahead and draw this line so it looks a little bit more like a triangle so we can see that rotation. Okay, so with the triangle there, it makes it a little bit easier to see how that green triangle in quadrant 1 has rotated a full 180 degrees and turned around and is now in quadrant 3. Up next, I just want to show you the difference in a rotation that spins around the origin, because we have been spinning around the origin, and one that spins around a vertex. So vertex A. What that means is that here at vertex A, it's like, okay, you see my little blue? Okay. It's like I kind of stick a nail in it, and vertex A is not going to move. The rest of the shape is going to spin around, and it said 90 degrees clockwise, so I'm moving this way, going to spin around A. So A stays exactly where it is, and I'm going to take what is a straight line here and bring it all the way around. How far is that? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. My B would spin to here. And then my C would also spin 90 degrees. And that looks like it would be here. Now let's go ahead and get some lines on that so we can see it. Okay, so that makes a little bit more sense. I'm going to go ahead and label C here as well. That when we have a spin around a vertex, we're not moving quadrants, we're just spinning it around a place. And they told us to stick the nail, so to speak, in A and slide everything around it. So vertex movement is different than origin. Most of the time you will see origin. So I just wanted you to see the difference in case they give you just a different word.